Hello. What we're going to do today is a problem regarding the conservation of momentum. The conservation momentum simply states that the initial momentum will equal the final momentum, that the system remains unchanged relative to the total momentum in the beginning versus the total momentum at the end. Terrell, a football player, throws his .20 kilogram football in the living room and knocks over his mother's .8 kilogram antique lamp. After the collision, the football bounces straight back with a speed of 3.9 meters per second, while the lamp is moving at 2.6 meters per second in the opposite direction. How fast did Terrell throw the football? Now, Terrell is throwing the football and hits the lamp. The forward direction of the ball will be considered to be positive. If the football goes backwards, then it would be considered negative. The lamp goes forward, and that is positive. This slide simply states that the initial momentum will equal the final momentum. Remember, the momentum is simply the mass times the velocity. The system is made of the football and the lamp. So, the mass of the football times the initial velocity of the football plus the mass of the lamp times the initial velocity of the lamp will equal the mass of the football times the final velocity of the football plus the mass of the lamp times the final velocity of the lamp. The mass of the football will be .2 kilograms. The mass of the lamp will be .8 kilograms. Notice that the lamp is considerably heavier than the football. Now remember, we're trying to find the initial velocity of the football. Notice that the football is going to bounce straight back. So if the forward motion of the football, that is the football before it hits the lamp, is positive, then if it bounces backwards, it will be negative. So it'll be negative 3.9 meters per second. The initial velocity of the lamp is 0 meters per second because it's standing still as Terrell throws the football. As the lamp is struck, it is going to fly forward. Now the forward direction is going to be positive, so the lamp is going to fly forward at 2.6 meters per second. Now, finally, we're going to be looking for the final velocity of the football. Now we're ready to plug in the values, and you'll see those at the bottom of the slide. Notice that we are looking for the initial velocity of the football, that the initial velocity of the lamp is 0, so that will cancel, and then make sure that you multiply 0.2 times a negative 3.9. That's a separate product, that's a term, and then you're going to add that to 0.8 times positive 2.6. Make sure that you're careful to keep the signs organized. Now notice a few things here. You have a negative 0.78, add that to a positive 2.08, that sum will be positive. Now, the 0 will cancel, so you'll be left with 0.2 kilograms. The initial velocity of the football equals that sum. Be careful that the sum will be positive. 2.08 is greater than a negative 0.78. Now this is key. You'll see that the left side is going to be 0.2 times the initial velocity of the football, and the right side will be a positive 1.3. Therefore, the velocity has to be positive. And that makes sense to us because that's the initial velocity of the football, and we're throwing the football forward. The lamp is going forward, and the football is coming backwards. So the initial velocity of the football should be positive. And now we will see that, yes, when you divide through, it's going to be a positive 6.5 meters per second.